Hello students, this is our second lecture of Audio Video Engineering, Unit 2nd, Digital TV and Display Devices. In the first lecture, we have seen what is actually the digital TV, what is definition of digital TV. We have seen the introduction to the digital TV, how actually the digital TV works, and we have seen the difference between analog televisions and digital television. What is the working principle we are using for the digital TV we have seen, and then we have seen different formats or different quality standards for the digital television and difference between the analog standards and digital standards we have seen till now. Today we will see the digital TV transmission types. You can see in the diagram that is classification of television transmission. First of all, we will see how actually the television transmission is classified. The television transmission is initially classified into two types, that is analog television transmission and digital television transmission. The particular analog television transmission that was convert or divided as analog TV transmission, we were having three types: PAL, NTSC and SECAM. Few countries have already stopped and many countries have announced to stop the analog television transmission, that is PAL, NTSC and SECAM type of transmission, and they are using digital transmission for the now. That particular analog transmission was divided as terrestrial broadcasting, satellite broadcasting and cable broadcasting. This is stopped in many countries now. Now let us see how the digital TV transmission is classified. The particular digital TV transmission is classified as composite encoded digital television transmission and component encoded digital television transmission. Means first is composite encoded and second is component encoded. That particular composite encoded television transmission or digital television transmission is divided as same as that of the analog television transmission, that is terrestrial broadcasting, satellite broadcasting and cable broadcasting here. But the composite encoded digital television transmission is subdivided into two types, that is MAC, that is MAC, multiplexed analog technology component, and second one is advanced digital television technologies. The MAC is subdivided into same terrestrial broadcasting, satellite broadcasting and cable broadcasting. The terrestrial broadcasting is not applicable nowadays. And advanced digital television technology is also divided as terrestrial broadcasting, satellite broadcasting and cable broadcasting, which is having three types each, that is ATSC, which is Advanced Television System Committee. Second one is DVB, that is Digital Video Broadcasting System. ISDB, that is Integrated Services Digital Broadcasting System. Now, in this lecture, we will see in detail, that is ATSC, DVB and ISDB. Okay. The standards for digital TV transmission are: digital TV is a television in which the picture information encoded into the digital signal on are transmitted and decoded at the receiver. Means it is encoded at transmission and it is decoded at receiver, and we will get the same signal at that was transmitted from the transmission. The standards for digital television are ATSC, as we have seen now, it is Advanced Television System Committee, that is used in USA and South Korea. ISDBT, that is Integrated Service Digital Broadcast, that is used in Japan and Brazil. DVB-T, that is Digital Video Broadcast, that is used in Europe, Asia, Africa, Australia and New Zealand. You can see the image below that which shows the standards, which standard is being used where, in which country, which standard is being used, that is shown on the image. It can be clearly seen on that image. Means by the image we can say that the India is using digital video broadcast, because the blue sign or blue color is given to the DVB telecast system or standard, that is clearly showed on the India map. Here we have seen this classification. In that we will see the digital TV transmission. First, it is divided into composite and component. In the case of composite encoded DTV signal, the Y, U and V signals are acting as color-plexed composite video signals. Thus, the CCVs, that is color-plexed composite video signal, is sampled, quantized and encoded, and then it is modulated with the digital continuous wave modulation technique like the QPSK, and the transmitted. After that, after the modulation, they are transmitted. The transmission can be terrestrial broadcast, satellite broadcast or cable broadcast, as we can see in the image. In case of that component encoded digital TV signal transmission, we have seen the two types, that is MAC encoded DTV transmission and advanced DTV transmission. In the MAC, the full form of MAC is multiplexed analog component DTV transmission. In that, the Y and U and V signals are time compressed but analog in nature. The signals are compressed but they are analog in nature. Sound and synchronization signals are sampled, quantized and encoded by using the PCM technique, because we are having whatever the signal, that is digital signal. Also, the digital compression is applied to the audio and synchronization signal. Thus, the time compressed video signal, that is digital audio and synchronization signal, are multiplexed and frequency modulated, and then they are transmitted. Transmission that can be done by using satellite broadcasting, cable broadcasting, but the terrestrial broadcasting is not applicable for the MAC DTV transmission. In the advanced DTV technology, that is second type of component encoded DTV transmission. In the particular advanced DTV transmission, Y, U and V signal, they are separately sampled, quantized and encoded by using the PCM technique as in the MAC technique, but they are separately sampled, they are not sampled at the same time. The different sampling standards are also there in existence, like 4:2:2 sampling, 4:2:1 sampling, or 4:2:0 sampling, etc. These all the individual bit stream is added with the help of adder, and compression is applied to reduce the bit rate. Here in this case, whatever the sound signal we are having, that is sampled and quantized and then encoded by using the same PCM technique. Also, the digital compression is applied to the audio signals to reduce the bit rate. The particular this video and audio bit stream is then multiplexed and modulated with the digital continuous wave modulation techniques like QPSK, and after that, that is transmitted. The component encoding is more attractive, that is being independent of color system standards, frame stores and noise reduction, and spatial effects are very easier in component encoding. The transmission that can be terrestrial broadcast, satellite broadcast and cable broadcast, as we can see in the image. The modulation techniques that will be different from the terrestrial broadcast, satellite broadcast and cable broadcast, means whatever modulation, either PCM or any other modulation, QPSK we are using, that will be different for all these different standards. Now let us see how the composite encoded DTV transmitter will work. That particular composite encoded DTV transmitter is having video camera, then it is having adder circuit, then ADC circuit, video compression block, and it is having preamplifier unit for the purpose of sound collection. Then it is having ADC, then audio compression block is also present. Then all the signals will be given to the MUX or digital multiplexer, and QPSK or the modulation technique will be performed, and then it will given to the antenna or it will be transmitted. Now let us see how that particular composite DTV encoded DTV transmission will be done. In the case of composite encoded DTV transmitter, whatever the video camera that will be used used in the DTV transmitter, that will be having basically a color camera in which RG and B signals are processed and Y, U and V signals are generated from the camera, as we have seen in the last unit also. Whatever the adder circuit, that adder circuit will be used for adding the U, V and Y signals along with the synchronization signal of the series signal. Thus color plexed composite video signal will be produced. After that, whatever the adder will produce the color placed composite video signal that will be available at the output of that particular adder circuit. After that, we are having ADC circuit. The ADC is nothing but analog to digital converter. In that ADC blocks, the sampling of CCVS, that is colorplex composite video signal, will be done at Nyquist rate, and then PCM encoded digital bit stream that will be available at the output. The typical video signal, that is the video signal ADC converter, will be done by the PCM encoding technique. Then the entire CCVS signal that is being converted into the PCM digital bit stream. Thus, the quantization of that analog CCV signal into the discrete level will be done in the ADC. You can see the block diagram of that particular composite encoded Dtv transmission for the transmitter, which is having video camera. The output of video camera is Y, U and V, the particular signals. All the Y, U and V signal will be given to the adder circuit that will produce the colorplex composite video signal, which will be given to the ADC. Analog to digital conversion will be done, and after that we are using PCM modulation technique for the purpose of modulating video signal that here. After that, we will see whatever the bit rate of the ADC output or the PCM signal that is done after the ADC is very high. For the purpose of reducing the bandwidth of requirement, digital compression techniques, we are using here video compression blocks. That digital compression technique like MPEG2 is applied, hence compressed video signal will be having bit stream which will be available. Also, we are having the audio signal. Okay, the audio signal from the mic is pre-amplified, digitized using ADC, and then it is compressed by using audio compression techniques. Whatever the compressed video signal and compressed audio signal we are having, that both the signal are multiplexed by using the digital multiplexers. Thus, we can see here the output bit stream from the multiplexer is then modulated by using the digital continuous wave modulation technique like QPSK, and it is transmitted or it is broadcasted for the purpose of broadcasting. This is how the particular composite DTV signal transmitter works. Now we will see how that particular receiver will work. DTV receiver for the composite encoded video signal, we can see the diagram below the transmitter diagram. The antenna that is used for the reception of the signal, QPSK receiver, demodulates the QPSK signal. Then demultiplexer we are having. The demultiplexer is used to separate the audio and video signal. We have multiplexed both the signal in the transmitter. Here we are demultiplexing that particular signal by using the demultiplexer block. They are used for separating audio and video digital data bit streams. Then separated audio bit stream is decompressed using audio decompressor, and it is given to the DAC. As we have performed ADC, here we will perform DAC, digital to analog conversion. Then audio DAC converts the signal into analog, and then the signal is given to the audio codec and then audio processor block. After that, codec, that stands for coder decoder, which converts the analog signal into the digital signal, then processed by audio processor. Again, it is given to the audio codec, which converts the digital audio signal into the analog audio signal. Whatever the audio processor is used to give the different audio effects in the DTV receiver. Thus, analog audio signal from the audio codec block is given to the audio preamplifier, then power amplifier for the current boosting purpose. Thus, the sound is available at the output of the speaker. This was all about the audio signal. Then demultiplexer output video signal. Whatever the audio signal we have seen, how that audio signal will be going under the different blocks or different processes. Then the output video bit stream that is given to the video compression, where compressed video bit stream is decompressed again. We have compressed the video bit stream in the transmitter. That particular compressed bit stream will be decompressed again here, and then decompressed video bit stream output that is given to the video DAC, that is digital to analog signal, for the purpose of getting analog colorplex composite video signal. Thus, whatever the video DAC output that is given to the video codec, video processor block, video codec that converts the analog video signal into the digital video signal. Then that particular process by using the video processor, and then again it is given to the video codec, which converts the digital video signal into the analog signal. This is how the particular video signal is processed in this type. After that, we are using video processor that is used to give the different video effects like picture in picture, PIP, and slow motion effect in the DTV receiver. We can give different effects by using the video processor. Thus, in this section, we'll also facilitate the different video interfaces like A to B analog to video interfaces, Y PB PR interfaces, DVI interfaces, and VGA interfaces for various TV display monitors. Getting the concept of this particular type, that is composite encoded DTV transmission and reception, we can say from this discussion that is the advantages of DTV receiver. We can say that reduced gauge and EM interference due to the digital processing of the signal. Here all the processing of the signal is digitally. We are processing compression, then we are processing analog to digital conversion, we are using amplifiers, then we are using modulation techniques. All these techniques will be digital processing. It will be having reduced 50 Hz flicker effect. These are the advantages of the particular composite video signal DTV transmitter. In the component encoded DTV transmission, we have seen the first type is MAC, that is multiplexed analog component technology. Now we will see what is the need of this particular MAC technology. The EDTV, that is extended digital television, that is mainly intended for new delivery media such as the direct broadcast satellites. And a typical example is the multiplexer analog component, that is MAC system, that is used for DBS broadcasters. The problems that are faced in the DBS when AM VSB or FM modulation technique is used in KU band in frequency range, that is 11.7 to 12.7 GHz. AM VSB that cannot be used for DBS because of high power requirements or non-linearity of satellite amplifiers. That's why we need a MAC signals. For minimizing the power consumption, FM modulation technique was decided to be implemented with approximate bandwidth of 24 MHz or 27 MHz for a channel in KU band of 12 GHz frequency. This is how we need a MAC technology here. In case of MAC's technology, we will see the chrominance and luminance signal that are time compressed in this technology, and then they are transmitted with time multiplex rather than the frequency multiplex. Whatever the luminance component that is compressed by a factor 3:2, that is by a factor 1.5. So the luminance component that occupy the time which is reduced to 35 microseconds from the 52 microseconds. Then the chrominance component that is compressed by factor 3:1, that is by the factor 3. So the chrominance component will occupy the time which is reduced to 17 microseconds from the 52 microseconds. So it is not possible to transmit both U and V chrominance signals in every line. Thus, time compressed luminance information that is transmitted on every line along with one of the time that is compressed chrominance component, U and V, and then complementary component that is being transmitted in the next line. First two compressed chrominance component are transmitted U and V, and the complementary component that will be transmitted in the another line. Thus, we can say that the MAC, that is multiplexed analog component technology, This system can offer higher performance than the composite system. We have just seen the composite system. This particular MAC system that will offer the higher performance that composite system because of separation of luma and chroma signals, which will eliminate the cross modulation, and use of full bandwidth for luma and chroma signal will be done. In MAC, the picture synchronization is ensured by means of the time multiplex data signals. Okay, the signal power in MAC signal is greater as compared to the PAL system because of avoiding the use of the frame and the line synchronization signals amplitude. The process of encryption that is possible too in MAC signals for PAY channels. MAC signal is the best suited for direct reception of satellite programs by individuals and community antennas installations to the maintain high quality of the picture. By using this MAC signal, we can get the high quality for the particular satellite program that were telecasted for the individual or community antennas. That MAC can provide the multiple sound channels also. With MAC, the higher performance is readily possible because of the separate components used here. The programmability feature of the MAC's video and synchronization system has also the advantage of flexibility for future changes and improvement in the television system. The component coding that has advantage to change the required video format. In the MAC processing that will produce all 625 lines on each scan instead of interlaced scan. So the higher definition picture can be displayed by using MAC transmitter. The block diagram of DTV transmitter, that is typical MAC DTV transmitter, we can see here. It consists of time compression with the factor 1.5. Then for the Y signal, for the U and V signal, time compression with the factor of 3, and then ADC plus compression we are performing for the sound signal and synchronization signals. Then we will give it to the multiplexer, and the FM modulation will be performed over there. Now let us see in detail how this MAC DTV transmission will work. The time compression with factor 1.5 is applied to luminance signal. Time compression with factor 3 is applied to the chrominance signal. Sound and data signal and the synchronization signal are converted into the digital signal using ADC. Then digital compression is applied to these particular signals over here. Thus, the time multiplexer is used to multiplexer the time compressed Y, U and V signals with digitally compressed sound, data and the synchronization signals. Thus, these multiplexed analog component MAC signals are FM modulator for satellite uplink for typical DBS, that is digitally broadcast satellite broadcasting. Then also this multiplex analog component signal, that is MAC signals, are AM and VSB modulated for the purpose of cable broadcast. We can use here for the two purposes, for satellite broadcasting and for cable broadcasting. For MAC signal, terrestrial broadcast is not used ever before. It is not applicable for the terrestrial broadcasting purpose. For the MAC signal, the terrestrial broadcast is not applicable. Thus, the MAC DTV transmitter is used to transmit the MAC signal for DBS broadcast by using FM modulation, and for cable broadcast using AM VSB modulation. We are using two different modulation processes, FM for the satellite and AM VSB for the cable distribution. Now let us see the MAC DTV receiver block diagram. The block diagram you can see shows the MAC DTV receiver. FM modulators for the DBS receiver signal from the satellite, and AM VSB demodulators for the cable receiver signals. We have seen the two modulation technique for the different purposes. Here two demodulators will be used for the purpose of different receivers. Here two types of signal can be received and processed, like FM modulated DBS signal that will be used for satellite purpose, and AM VSB modulated signal that will be for the cable purpose. FM demodulator is used for DBS signal from the satellite, and AM VSB modulator is used for cable receiver signal over here. Thus the MAC signal is given MAC decoder. MAC decoder performs the functions as demultiplexing of compressed Y, U and V sound and data synchronization signal, then time decompression of Y, U and V signals, and then digital decompression of sound, data and synchronization signal. Decompressed audio bit stream from MAC decoder that is converted into the analog audio by D to A converter. Then analog audio signal is then pre-amplified and power amplified by amplifier stages, and then finally it is given to the speaker. The MAC technology, it will support the mono, stereo as well as 5.1 digital theater multi-track audio system, and hence accordingly the audio processing stages that can be modified. Decompressed video signal from MAC decoder is then processed in video processing stage. Decompressed synchronization signal bit stream from MAC decoder is then converted back into the analog by D to A converter, and then further it is processed into the video processing stage. Now video processing, in the video processing stage we are having video processor that is used for giving different video effect like picture in picture, that is PIP, or the slow motion effect in the DTV receiver. This section will also facilitate the different video interferences like AV interferences, YPB, BR interferences. Clear all the concept? Now till now we have seen the composite encoded DTV transmission and reception, and after that we have seen the component encoded. In that we have seen MAC signal or MAC technology, that is multiplex analog component technology for the purpose of transmission and reception. Now let us discuss the advanced DTV technology. In the advanced we are having ATSC, DVB and Isdbt system. Now let us see ATSC system. ATSC is Advanced Television System Committee. The modulation used in ATSC is 8 VSB, that is in some ways similar to the analog NTSC based on the single carrier. The modulation technique that provides 19.39 Mbps data payload in 6 MHz TV channels. It is possible to transmit one HDTV program or up to 4 standard definition programs in single 6 MHz channels. The transport stream that is used in MPEG-2 and audio coding, that is Dolby Digital AC3 format, 5.1 channel surround sound providing theater like quality audio. The various auxiliary data casting services are also possible in this particular of ATSC system. Now let us see DVB-T. This is second type of system, that is digital video broadcast terrestrial system. In this particular type of DVB-T, it uses coded orthogonal frequency division multiplexing, that is OFDM modulation, and it supports hierarchical transmission that provides the data payload up to 90 Mbps. That was 19.39 in before system, that is ATSC system. It is developed by Digital Video Broadcasting Project Group, DVB. It uses similar technology to DRB. It is possible to transmit one HDTV program or up to 4 standard definition programs in a 6, 7 or 8 MHz channel. The used transport streams are MPEG-2 and MPEG-4 AVC. DVB-T that can also provide mobile handheld services, data casting and interactive services. This is all about the digital video broadcast terrestrial system. This technique is mostly used in Europe, Asia and Australia. Now let us see the next system, that is Integrated Service Digital Broadcast Terrestrial System, that is ISDBT system. This ISDBT system also uses the COFDM modulation with almost all the same techniques as DVB-T. In this technique, it is possible to transmit one HDTV program or up to 4 standard definition programs plus one segment of program for cell phones and other portable mobile devices in a 6 MHz television channel. The transport stream used for the HD and SD programs is MPEG-2, while for one segment MPEG-4 AVC is used here. It can also provide the data casting and interactive services. It uses the time interleaving technique, which providing more improvement in reception performance easily under the noisy mobile and indoor reception conditions. COFDM system integrates all forms of broadcasting services into one common data channel, which can be passed by the satellite cable or terrestrial delivery system for video services and sound services, bulk data services, and interactive data services. This is all about the integrated service digital broadcast terrestrials. Okay, now let us see different features and development comparisons. You can see in the comparison boxes that technical comparison is given for different system ATSC, DVB, and ISDBT, and features also we have seen in this. Now let us see DVB-T and ISDPT are similar in some ways because they use the same multiple carrier COFDM modulation technique. This allows the two standards to provide the mobile broadcast services and deploy the single frequency network in same geographical area. Digital terrestrial multimedia broadcasting, it adopts the time domain synchronization TDS OFDM technology with pseudo random signal frame to serve as the guard intervals of the OFDM block and the training symbols. The digital multimedia broadcast system is digital radio transmission technology that is developed for sending multimedia such as TV, radio, and data casting to mobile devices such as mobile phone, laptops, and GPS navigation system.